Welcome to Cambridge Chemistry channel with Sarvat Ahmed. You all are requested to subscribe the channel and like the video. Today I will discuss the question number 2, most 2 of the paper 3, and you know that in paper 3 mostly question 2 uh, consists of enthalpy change. मोस्टली जो क्वेश्चन आता है आपको क्वेश्चन 2 का वो एंथैल्पी चेंज होता है, एंथैल्पी चेंज क्वेश्चन और थर्मल डिकम्पोजिशन क्वेश्चन और water of crystallization, to find out the water of crystallization. Water of crystallization. So I have discussed enthalpy change questions and water of crystallization. Now thermal decomposition. Today in this video I will discuss thermal decomposition question. So let's start. In this question, in question 1, you measure the volume of carbon dioxide. This is linked with the question 1 of the paper. Produced by metal carbonate in order to identify M. M is the metal, unknown metal. In question 2, you will identify another group 2 metal Q by using a gravimetric method. You know, gravimetric method is term used to a weight measurement. Gravimetric method is one in which the analysis is completed by weighing operation. So gravimetric can be defined, gravimetric methods can also be defined as the quantitative method based on determining the mass of a pure compound to which the analyte is chemically related. So I will write down gravimetric method definition. It can be defined as the quantitative methods based on determining the mass of pure compound to which analyte is chemically related. So this is known as gravimetric method. Now in this question, when two group 2 carbonates are heated, they decompose. We know that group 2 carbonate, this is group 2 carbonate. So when it decomposed, always gives metal oxide and carbon dioxide. This is the residue and this is gas which is evolved during this reaction. So Fe3 is the metal carbonate, QCO3 is the metal carbonate. Weigh the crucible with its lid and record the mass. Add between 1.30 gram and 1.50 gram of Fe3 into the crucible. Record the mass of crucible, lid and Fe3. Place the crucible on the pipe clay triangle on the tripod. This is the crucible and this is the lid. This is the type of, this is crucible, and in this QCO3 or metal carbonate is placed. Now it is placed on the pipe clay triangle. This is the pipe clay triangle on the tripod. This is the tripod stand, and this is the apparatus of this gravimetric method. So balance is also there. So this is crucible and this is lid. Place the crucible on the pipe clay triangle on the tripod. Put the lid on the crucible and heat gently for approximate 1 minute. Why lid is necessary on the crucible? To absorb water vapors from the air in the content. Use tongs to remove the lid and heat the crucible. Tong is like, this is the tong. This is the holding of the tripod stand, like this. This is the tong, and you will use tong to remove the lid and heat crucible strongly for approximately 5 minutes. Replace the for 5 minutes. First 1 minute and then for 5 minutes, approximately for 5 minutes. While the crucible is cooling, begin work on question 3, because 5 minutes you require, you need to work on question number 3, and that is a lengthy question, so don't waste your time 5 minutes. So meanwhile you can start question number 3. When cool, reweigh the crucible with its lid and contents. Record the mass. Calculate and record the mass of Fe3 placed in the crucible. Calculate the record the mass of residue left after heating. Keep the crucible and its content for use in question number 3b. So follow the instructions carefully and read the instruction of the method very carefully. So follow these instructions to carry on the question. So draw the neat and neat table. Use scale. टेबल बहुत क्लियर होना चाहिए. You should use pencil and neat pencil and ruler. Mass of crucible plus lid. This is very important to weigh the mass of crucible with lid and write down always in your table. This is this should be mentioned, lid plus, this is the mass of table, mass of crucible and lid, or that is I write down the reading, just suppose the reading, this is, and write down unit as well, 19.15, and write down the mass 2 decimal place. Mass of crucible plus lid plus Fa3 gram. So for example, this is 20.40. Mass of Fa3, just subtract this mass from the mass of crucible. 20.40 minus 19.15, this is equal to 1.3. 20.40 minus 0.15. So this is 20.45. This is 20.45. I just pose the readings. Mass of Fa3 gram. So mass of crucible plus lead plus residue after heating. This is equal to the 18.53. Don't forget to write down the unit. Mass of Fa3 used. (19.15 minus 18.53). This is equal to 0.62. So this is mass of residue grams, a mass of carbon dioxide, or you can say lost mass lost, or mass lost. This is gram. 1.3 is the mass of Fa3, and mass of F3 used, that is 0.62. So this is equal to 0.68. This is the mass of carbon dioxide. So calculate the number of moles of carbon dioxide produced during heating of Fa3. Calculate the number of moles of carbon dioxide produced during heating of Fa3. So we have mass of carbon dioxide, so we can calculate the mole of carbon dioxide is equal to mass over mR, which is 0.68 divided by 44. The answer is 1.55 into 10 raised to 2 - 2. Use the mass of Fa3 in A and your answer to be 1 to calculate the relative atomic mass AR of Q and hence identify Q. You should assume complete decomposition of QCO3. We know the mole ratio of QCO3 ratio carbon dioxide. There is 1:1 ratio in the chemical equation. We use this equation. This is the QCO3. Okay. the mole of carbon dioxide into 10 raised to minus 2 ratio x. So we have mole of carbon dioxide is equal to 1.55 into 10 raised to minus 2. So now we can calculate the first MR is equal to mass over mole. So mass we use 1.3 of QCO3. So MR is 1.3 divided by 1.55 into 10 raised to minus 2. This is equal to 83.87. Now we can calculate 83.87 Q plus 60, carbon is 12, oxygen is 16 into 3 is equal to 83.87. Q is equal to 83.87 minus 60 and Q is equal to 23.8, approximately 24. So AR of Q is magnesium. AR of Q is 24 and the metal is Q is magnesium. Okay, explain why the lid was placed on the crucible when the residue was left to cool, so that water vapor from air not absorbed. In order to decompose group 2 carbonates, solid must be heated strongly. In this experiment, QCO3 was heated for a few minutes. Suggest an improvement to the method used that would ensure the decomposition was complete. Heat to constant mass. Suggest a chemical test to determine whether the decomposition of QCO3 was complete. State the expected observation if the decomposition was incomplete. Add an acid. If carbon dioxide is evolved, which turns lime water milky, shows incomplete decomposition. If carbon dioxide does not evolve, shows identify the complete decomposition. In your calculation in B, you use the mass of QCO3 and assume that it was all decomposed during the heating. Explain what effect incomplete decomposition would have on the calculated value of the AR of Q. So if mass lost is too low, moles of carbon dioxide is also too low. So, if mass loss is too low, mole of carbon dioxide is also too low, so then MR is too high, because we know that MR is inversely proportional to the mole. By using this MR, we know that MR is equal to mass over mole. If moles are smaller, then MR is larger. If mole is larger, then MR is smaller. So we know that mole is as MR as MR is inversely proportional to mole. So if there is incomplete decomposition, obviously mass lost is too low, so it affects the AR of Q. So ARQ will be very high. A student suggested that you could use the mass of the residue QO rather than the mass of QCO3 in a calculation of to identify Q. So there is no difference, because the ratio between QCO3 and QO is same, 1:1 ratio between QO and QCO3, and similarly QO is carbon dioxide, and the ratio of QO to carbon dioxide is also 1:1. As ratio of QCO3 to O is equal to 1:1. So if QCO3 is QO and QO ratio carbon dioxide is also 1:1. So it does not matter that by using mass of residue QO rather than the mass of QCO3. Hopefully you got it.